Hello friends, I am Hitesh, and in this session I am going to solve for you algebra questions taken from CAT 2016. Now, these questions are memory based. I hope you guys will stick till the end of the session. You'll notice in 2016 some questions were very easy and you could answer those questions by simply replacing couple of numbers in X and get the answer. But in the next few sessions, I'll be solving for you questions from CAT 17, 18 and 19 for algebra. In those, you'll notice value replacement is not going to be an easy thing. So let me dive into this. What is the range of X satisfying this inequality and this inequality? Here, I notice range is from -5 to 4, -1 to 4, -5 to 3 and 3 to 4. Easiest values to replace and check are 0, 1 and -1. If I replace 0 in the first inequality, it becomes 0 plus 0 minus 15. Is it more than 0? No, it is not. So 0 does not fit this inequality, first one. I'm looking for the range of X that fits both inequalities. And as 0 does not fit here, this option is gone, this option is gone, this option is gone. The only option available is option D. That is the answer, guys. All I did in this problem was replace X is equal to 0. When you have multiple inequalities and you're looking for a common solution is the overlap of the ranges available. Let me try and thoroughly solve this for you. See, this equation that I have, first equation, I can factorize as x square plus 5x minus 3x minus 15 more than 0. I can factorize this further as x plus 5 common minus 3 common x plus 5 more than 0. So that breaks down to x minus 3 into x plus 5 more than 0. Now, in our theory sessions, we cover something called as wavy curve method. I'll have to apply that here. This bracket gives me the root point as 3. This bracket gives me root point as minus 5. Outside plus, then minus, then plus. I need positive. So I need to take values on the right side of 3 and on the left side of minus 5. That is the range of X for the first inequality. Second one, I can factorize this as pretty simple. X minus 4 bracket x plus 1 less than 0. I broke this down as sum of two terms and this one as product of same two terms, that is minus 4 and 1. Now here, see, 4 is a root point and minus 1 is a root point. So right side is positive, then negative, then again positive. Here I want values below 0. So below 0 is negative, that is between minus 1 and 4. As you can see, those black lines with arrows represent the range for the first inequality and this blue line with arrows represent range for the second inequality. The common overlap is only possible between 3 and 4. So that is our answer here, between 3 and 4. This is how we can thoroughly solve this problem. First method that I had shown you was option replacement or value replacement. Let us try the next problem. What is being said here? P, 2P, Q plus P, 2P minus 2Q minus 6 is a AP. What is the 99th term? In an arithmetic progression, all you have to do is find the first term and the common difference and you're good to go. Here the first term is given to me as P. Second term is given to me as 2P. So I understand the common difference here is P. So by this logic, the next term should have been 3P. But I have been given the value of Q plus P as the third term. This tells me Q must be 2P. If Q must be 2P, see, by this logic, 4P should be the next term. And that has been given to me as 2P minus 2Q minus 6. So here if I send this 2P on the opposite side, I will have 2P is equal to, if I put 2P here, I will have minus 4P minus 6. If I rearrange this, I will have 6P is equal to minus 6, P is equal to minus 1. For me, the sequence turns out to be minus 1, minus 2, minus 3, minus 4, and so on. What did we want? We want 99th term. It is going to be minus 9. All I did in this problem was apply the common term of AP. A, A plus D, A plus 2D, and so on. I found out A is P and the common difference is also P. So my AP becomes P, 2P, 3P, and so on. I found out P to be minus 1. So I get the answer as minus 99 as the 99th term. That is the answer option A, first answer option. Let us try the next problem. What is being said? Find total number of non-zero integral points strictly inside the curve. When we say inside the curve, the value cannot be equal on both sides. You cannot have LHS is equal to RHS. RHS is the constant. LHS left hand side must be less than RHS for all the pairs of X and Y inside the curve. Here I will have to do some degree of manual testing. See, I cannot put any of X or Y as 0. So if I put X as plus or minus 1, I will get the square 1. So Y square can go up to 15, up to 14. That means Y can be plus minus 1, Y can be plus minus 2, Y can be plus minus 3. So there are two values for X and there are 2, 4, 6, 6 values for Y. So there are 12 pairs for X and Y. There are 12 pairs. If I put X is equal to plus minus 2, I will get a square of 4. So Y can go up to 12. Y square can go up to 12. So Y plus minus 1, plus minus 2, plus minus 3. Because the squares are 1, 4 and 9. Plus 4. I have not crossed 16, I have not reached 16. So still two values for X plus and minus 2 and 6 values for Y. So 12 values for pairs of X and Y. If I put plus minus 3 for X, so I have got 9 here. The square is 9. So here Y cannot go up to 3. Why? Because it will become 9. So Y can go from plus minus 1 to plus minus 2 because squares of 2 plus minus 2 will go up to 4. So we can go up to 13, that is fine. So 2 values for X and 4 values for Y gives me 8 values total. If I increase X further, my left hand side becomes equal to right hand side, which is not valid here. So how many solutions do we have total integral pairs? 12 plus 12, 24 plus 8, 32. That appears to be answer option B. Let us try the next problem. Here I see an equation of degree 4. I see 4 brackets being multiplied for X plus a constant. I am supposed to simplify this equation and then see which of the answer option matches. I see X has been multiplied here with the 3 brackets. So what I am able to visualize here is if I put X is equal to 0, I am looking at product 0 plus 16. So I'm looking at output of 4. That tells me for X is equal to 0, I should be able to generate 4. If I put 0 in this, the outcome is 5. If I put 0 in this, the outcome is 9. If I put 0 in this, the outcome is 4. If I put 0 in this, outcome is 5. So there is only one answer option that gives me an outcome of 4. Answer option C. What I was able to do in this problem was I was able to verify the constant part. When you put x is equal to 0 in any equation, all the terms are cancelled and you are able to verify the constant. Let us say if I wanted to thoroughly solve this, you will have to observe some patterns here. I'll be multiplying first and the last term. See, I'm not writing square roots here. I'm multiplying first and the last term, and I'm multiplying second and the second term, second and the third term. See what that leads to. X square plus 6x bracket. See, there is plus 16 at the end. I'm not manipulating that. This will give me x square plus 6x plus 8 plus 16. Now, here the idea behind multiplying first and last, second and third term was I get x square plus 6 in both. If I call that k, I have got k into k plus 8 plus 16. If I rearrange that further, I have got k square plus 8k plus 16. Now what is that square of? That is square of k plus 4. Now if I bring in the square root, see there was always a square root, I was simply not writing it there. If I bring in the square root, I will have k plus 4 as my outcome. What was k? X square plus 6x plus 4. That is again answer option C. If you plan on thoroughly solving such problems, you will first have to notice some pattern in coefficients and constants. I chose to multiply first and last and second last terms, so I can generate a common value in both. Now, since last 4 years, questions on logarithms have become very common in CAT, and usually they involve deep understanding of how to manipulate base of the log. Here, let us try this problem. What is being said? Find product of all possible values of x. Does not say real values, it says all possible values. What I see here is on the left hand side I have got a base of 2, on the right hand side I have got a base of 4. Now 4 basically is 2 square. So what I can do is I can rearrange for you the right hand side term as 1 by 2 log of 6x square minus 65x plus 189 with a base of 2. See, the base was 2 square. The power of the base comes in the denominator, guys. This 2 I can multiply on the opposite side. It will become the square here. So what I have got here is log of 2x plus 3 whole square with a base of 2 is equal to log of 6x square minus 65x plus 189 with a base of 2. Now see, this is not an inequality based question, so I can easily cancel log with the same base on both sides. That generates 4x square plus 9 plus 12x is equal to 6x square minus 65x plus 189. If I rearrange that, if I send these values on the right side, I will have 2x square minus 77x plus 180 is equal to 0. Now, product of roots of a quadratic is available as C upon A, which is 90 in this case. That is the answer option C. How did I decide that I should follow this approach? As soon as I see a quadratic equation in the bracket, and as soon as I read the question part, the question says find product of all the possible values of x. That gives me a hint that if I'm able to convert this entire equation into a single quadratic, the product is available as C upon A. If you convert the entire thing as a quadratic of the form ax square plus bx plus c is equal to 0, product of roots is available as c upon a. So all I have to do is find out c and find out a, and my answer is ready. Let us try the next problem. Average of 15 distinct unequal natural numbers is 13. What can be maximum of these numbers? So what I hear is I need to add 15 numbers which are different. They are positive integers, that is what natural numbers mean. And I want the average to be 13 and I want maximum of those numbers. So I get an idea. If I keep the values on the left hand side as less as possible or as small as possible, the last value remaining will be maximum possible. Smallest natural number is 1, then distinct value 2, 3, 4 and so on, so on and so forth. I've got 15 values. So in this manner, I plan to go up to 14. This is sum of all numbers. 13 is the average. There are 15 numbers. So I get a sum of 195 total. Now this is nothing but sum of natural numbers. The formula that works here is n, that is 14, into n plus 1, 15 by 2, and the last value I am taking as x. Cancelled 7. 7 into 15 is 105 plus x is equal to 195. Rearranging that, I get 90 as my largest value possible for x. What thought process are we able to apply here? What is the idea here? See, if you keep all the numbers pretty close or close as possible, then the last value or the remaining value will be maximum. Now, what does the next problem say? In a group of 100 people, the number of people like apple are multiple of 16. Those who like banana are multiple of 14, and those who like both are multiple of 17. All people like at least one fruit. Find the number of people who like apples. This sounds like a question on set theory based on two sets. People who like apples are multiples of 16. People who like bananas are multiples of 14, and people who like both are multiples of 17. And everyone has to like something, at least one fruit, so outside value is 0. So sum of these terms, x, y and z based terms, should be equal to 100. And the question is, what is the number of people who like apples? I get a feeling that this question is based upon finding integral solutions for x, y and z. So let me try solving this. See, if I say the left hand side circle is complete 16, this portion is 14y minus 17z. So total number of people here are 16x plus 14y minus 17z. That is basically formula of union. Na plus nb minus the overlap of both. I want it to be 100. My focus is on being able to find x. Now, some idea about integer solutions. Coefficient of x and y is even. Coefficient of z is odd. The right side number is even. I am looking at even plus even minus something is equal to even. That tells me this has to be even. 17z has to be even. So z must be either 2 or 4 or values forward. Why can I not take z is equal to 0? 0 is not a multiple of 17, guys. I must have some natural number there. So if I start with z is equal to 2, what I have here is 16x plus 14y minus 34 is equal to 100. If I rearrange, I will have 8x plus 7y is equal to 134 by 2. That is 67. Now by trial and error, we have to put values of x and y and solve this further. So I'm able to apply hit and trial and say, let us say x is equal to 4. So you have tried this question earlier. You have to put x is equal to 1, x is equal to 2, x is equal to 3, and then verify values. So that gives me 32 here. If I say I need further 35 numbers, if I put y is equal to 5, I'm able to match 67. So that tells me x is equal to 4. See, if I put z is equal to 4, I get 8x plus 7y is equal to, this becomes 68 on the opposite side. So 68 by 2 is 84. Here, the values of x and y will be so large that the total value will surpass 100. So the only solution possible is x is equal to 4 and y is equal to 5. You wanted to know how many people like apples. That will turn out to be 64. If you try and solve this further, you'll find values of x and y surpass. I'll give you ideas. See, I can put y is equal to 12, x is equal to 0, then x increases by 7, y decreases by 8. So if you put 7 just here in 16x, you cross 102, 112. You cannot have that many values. That is why this solution is not possible. So this was a slightly time-taking problem. And in CAT, if you are not very comfortable with integral solutions, you should not be fooling around with this particular problem. Let us try another problem. If AN and SN represent respectively nth term and sum of first n terms of a GP, where A3 is equal to 3 times of S3 plus 2 and A4 is equal to 3 times of S3 plus 2, find the common ratio of geometric progression. In this question, I am being told A3 is equal to something and A4 is also equal to the same thing. So I am being told A3 is equal to A4. In a geometric progression, if two terms are equal, two consecutive terms are equal, guys, the common ratio is 1. That is what we are being asked for. Can you find the common ratio? Yes, the value of R that I have is 1. Because two successive terms are equal, the common ratio has to be 1. This was an easy problem. What is being said in this particular question? X plus 1, x plus b, and x plus 6 are in geometric progression, where x and b are positive integers. Positive integers means natural numbers. Then the value of b can be. See, when you come across questions can be, could be, you're looking for multiple possibilities. In this case, if you have answer options, I'll suggest you check answer options. What are we saying here? X plus b square is equal to x plus 1 into x plus 6. In a GP, we say if the terms are a, b, and c and they are in GP, we say b square is equal to a into c. Square of middle term is equal to product of adjacent terms. Let me expand this for you. X square plus 2bx plus b square is equal to x square plus 7x plus 6. So x square does not matter. X square is gone. Now, if I start with answer option placement, if I put b is equal to 2, I have got 4x plus 4 is equal to 7x plus 6. So 3x is equal to 2. I want x and b to be positive integers. That did not help me. If I put b is equal to 3, I will have 6x plus 9 is equal to 7x plus 6. If I transfer this, I will have x is equal to 3. Is it a positive natural number? Yes. With answer option B. And my job is done. I would not even go further from here because the question says what value can B take? Can it take value 3? Yes. That's it. Done. Can be, could be. If you have answer options to work with, go for answer options. If both the roots of equation x square plus ax plus 1 are real and negative, equation roots are real and negative, the minimum value of A should be. First of all, you want roots to be real. Real is the case when the discriminant is more than equal to 0. Here, I have discriminant as a square minus 4 more than equal to 0. So I have got a more than equal to 2 or a less than equal to minus 2. We'll come back to this. You want roots to be negative. See, values of roots are given by negative of the middle term, that is a in this case, minus root over middle term squared minus 4 into first and last term plus root over a square minus 4 into 1 upon 2 upon 2. See, I want this to be negative. I want both these values to be negative. See, if if a itself is a negative number, so minus minus becomes plus. This plus and this plus becomes positive. So I want a to be a positive value. If you focus on root b, a is a negative number. Imagine a is a negative number. Let us say a is equal to minus 4. If I put minus here, it becomes plus. And the square root is also added. So it becomes a positive root. Because I want both roots to be negative, a must be a positive number क्योंकि बेटा बाहर minus sign लगा हुआ है. So a being a positive number, this is my range. More than equal to 2. So what is the minimum available? 2 itself. So a is equal to 2 is the minimum value fulfilling all these conditions. You will notice in CAT 17, 18 and 19, every year there are 1 to 2 problems on quadratics and usually involving some maxima minima concept or some concept involving inequalities. This is a very common trend in CAT, guys. Cover quadratic equations in detail. Now what does the next problem say? There are two roads along the line 2x plus 3y is equal to 6 and 2x plus 3y is equal to 12. Another road is constructed equidistant from the two roads. Now the roads are constructed to join this road to an office located at origin. Find the distance of this road. Now let us first demystify the language. See, these equations that you are reading are parallel lines. If I call this line 1, if I call the other one line 2, these are parallel lines. You want another road parallel but equidistant from both. Furthermore, you don't just want this road, you want distance of this road from the origin. So first of all, when lines are parallel, they differ by their constant. This is 6, the other one is 12. The parallel line, for that to be equidistant, the constant of that should form a AP with the other two. That gives me value of C is equal to 9. This constant on the right side should be 9. It should be the average of the other two. So I have got the equation as 2x plus 3y is equal to 9. Now, distance from origin of a line is given by c divided by root over a square plus b square. Guys, this is theory of quadratics. Here c is available to me as 9 upon root over 2 square plus 3 square, that is equal to 13. So my answer is 9 upon square root 13. This question involves that you assumes that you understand this part. For lines to be parallel and equidistant, their constants must be in arithmetic progression. This can be very easily proven with help of coordinate geometry. We are not proving things here. We are solving questions. Let us try the next problem. Arithmetic mean of 7 numbers is 85. None of them is more than 100. Average of the first 4 numbers is 80. What is the least possible value of the fifth number? Alright. So what I observe here is I have been told that there are 7 numbers and their average is 85. So I can simply find the total. 5 into 7, 35, carried over 3, 56 plus 3, 59. This is sum of all 7 numbers. The average of the first 4 numbers is 80. So first, second, third and fourth. Their average is 80. That tells me their sum is 320. Now, we want to know what is the least possible value of this number. So this seems like a fairly easy problem. If I subtract 320 from here, I've got 275. Now, none of them is more than 100. So the maximum they can hold is 100. Because if I maximize the 6th and the 7th number, the 5th number becomes least by default. So if I give 100 and 100 to the 6th and 7th number, I've got 200. That tells me the 5th number should be 75 at the minimum, at the least. Language of such questions is usually confusing. People go into maxima minima theory. Yeah, this is very elementary level, average based question. I could have covered this question in averages mixtures as well. What is being said in the next problem? How many numbers have their cubes greater than minus 10 but their squares less than 70? We are looking for basically integers here. You want the cube of the number to be more than minus 10. See, here I can approximate and say if I take x is equal to minus 3 ka cube is minus 27. So I cannot go there. If I take x is equal to minus 2, I have minus 8. Is minus 8 more than this? Yes. So I can go up to minus 2, minus 1, 0 and so on. On the upper side, we are saying x square should be less than 70. So that means I cannot go to 9 because 9 square is 81. 81 is not less than 70. So I can go up to 8. Up to 8 I can go as the upper limit. So how many values are there from minus 2 to 8 including both? See, when the upper and the lower range are counted, it is first number minus the last number plus 1. Guys, there are 11 values that x can take, 11 integers that x can take. And yes, this is a question from CAT. This question involves on your understanding of squares and cubes. If you can find square root and cube root, or you can approximate values to the nearest integer, you're good to go. Let us try the next problem. I see a big equation in logs and I'm supposed to find the value of x. This gives me an idea. I should do something such that I can remove logs. Now I notice one thing here. If I transfer this 2 in the power, I've got 2 log base 2 log x base 10 square. There is no need to write base 10. Log means base 10. Now, guys, whenever you come across this representation, the logs are cancelled. See, if I say I have got a to the power log b base a, this will be cancelled out. That will be equal to b. As I have said earlier, the questions on logs for the last 4 years have been have been based on your ability to apply theorems on base or understanding of base. So what I have basically on the left hand side is log x square, on the right hand side log x plus log x square minus 1. So log x square I can cancel. I have got log x is equal to 1. The base is 10. There's no need to mention that. When you cancel a log, the base is raised by the power on the right side. So x will be 10 to the power 1. X is equal to basically 10 is your answer. Find the value of x is what we're looking for. That is equal to 10. Now let me explain this to you one more time. If you have a log of a base b is equal to c, and let us say you decide to cancel the log, base will be raised by power c. A will be b to the power c. That is the basic idea behind cancelling logs. This was a slightly advanced property. If you have not come across this, please take this down. Write this down somewhere and highlight this. Now, what do we have here? A commander was trying to arrange his soldiers in form of a square, but 63 soldiers were left. So he arranged them in form of two squares and there was no soldier left. What is the minimum number of soldiers? I understand when this person tries to arrange in a square, some value is left out, 63. But when he tries to arrange in form of two different squares, in this case, nothing is left out. Nothing is left out of the number of soldiers. So that tells me I should be able to solve this with some value replacement because the question is find minimum number of soldiers. I have got n square plus 63 as x square plus y square. If I put, see, I'll write down some squares 1, 4, 9, 16, 25, 36, 49, 81, 64, 81 and 100. Because I'm looking for the least value. If none of these values work, I will skip the question. If I put this as 1, 64, 1 plus 63 is 64. Can you form 64 as sum of two squares? 64. Can I form 64 as sum of two squares? 1 plus 49, 4 plus 36? No, I cannot. If I put n is equal to 2, I have got 4 plus 63 as 67. Can I form 67 as sum of two squares? 67. See, if I have 64, I need 3. If I have 49, I need 28. I do not have. So no, n cannot be 1, n cannot be 2. If I put n is equal to 3, 9 plus 63, that is 72. Can I form 72 as sum of two squares? I think yes. I can achieve this with 36, 36. It does not say that two squares must be of different dimensions. It says simply two squares are formed. So by putting n is equal to 3, I get a square 9. So he has 9 soldiers in the first form and 63 left over. If he combines two squares of 36 each, he is able to do the justice here, form two squares. So how many minimum soldiers are there? 72. This question should be solved through trial and error. Why? You have a single equation and three variables. You are not going to be able to solve it thoroughly. What does the next problem say? There are two arithmetic progressions, 2, 8, 14, 20 and so on and so forth. And then 2, 6, 10, 14 and so on and so forth. From the sequence A, terms that are common with B are deleted. What is the sum of first 10 terms of the remaining sequence A? Alright. This is my sequence A with a gap of 6. I'll write down a couple of values just to be on the safer side. And this sequence B, 2, 6, 10, 14, 18, 22, 26 and so on with a gap of 4. First, I need to cancel the common terms. See, 2 is common, 14 is common, 26 is common. So I notice what is remaining in A. The remaining is 8, 20, 32. Now guys, notice when you have terms equispaced in a AP which are remaining, that is a new AP. This is the common term A and the common difference is 12. What do you want? Sum of this new sequence up to 10 remaining terms. So 10 terms, the sum will look like 10 by 2, that is, this is the formula for sum, n by 2 plus 2a plus n minus 1 d. So first 10 terms, 10 by 2, 2a. What is a? 8. How many terms? 10. 10 minus 1, 9. What is the common difference? 12. My job is done. I can take out this 2 and cancel it with this. I've got 6 here. So I've got 10 bracket 8 plus 54. That is 62. 620 is your answer. Now, why did I write so many values for A? Just to see what kind of pattern do I get here. I notice when I cancel terms from A, I am left with alternate terms of A. That is a new AP. What does this problem say? An is equal to n by 100, bn is equal to 100 plus an. This is divided by, guys, this is divided by, there's this symbol missing, 102 minus an. For what value of n will bn be maximum? So if I notice here, bn is equal to 100 plus a upon 102 minus a. I want maximum value for b. See, I'm arranging this, rearranging this. I have got 10,000 plus n upon 102 followed by 20 minus n. 100 is cancelled, guys. Now to maximize this, I must have more numerator and less denominator. As you can see, more value of n will give me more numerator, and more value of n in the denominator will reduce the denominator. That is what I want. So I want n to be largest possible. Among the answer options, C gives me the largest possible value of n. I will have 10100 upon 10100. Output will be 1. So maximum value of B is 1. Does it say find the value of B, or does it say find the value of n? It says for what value of n will B be maximum? That is answer option C. Again, notice these are fairly easy problems because you are able to solve these with option replacement. This is not going to be this easy for CAT 17, 18 and onwards. Let us try this problem. What does it say? What is the value of B for which both have real roots? You want value for B for both to have real roots. When do we have real roots? When the discriminant is more than equal to 0. So here I get B square more than equal to 4 into 64. So I get B more than equal to, this will give me 2 and 8, 16, or B less than equal to minus 16. Guys, a square more than something opens outside both ranges. Very simple theory, guys. Second case, 8 square minus 4b is more than equal to 0. 8 square is more than equal to 4b. That is 64 by 4. 16 is more than equal to b. So where do I get a common overlap? This one says b is more than equal to 16. This one says 16 is more than equal to b. So the common overlap is b is equal to 16. That was the question. Can you find the value of b for which both roots have real roots? This part I'll explain you one more time. Whenever you have a square more than a number, x will open above the square root positive and x will open below the square root with a negative sign. That is how squares work. That is how inequality of squares work. I think this is our last problem. Now there's one more. What does it say? A sequence is such that difference of consecutive terms are in AP. All right. The first, third and sixth terms are 10, 2, 10, 37. Find the eighth term. All right. So first of all, I have got six terms. First, second, third, fourth, fifth and sixth. First term is 2, third term is 10 and the sixth term is 37. What am I being asked for? To find the eighth term. What is the hint here? But differences are in AP. The terms are not in AP, differences are in AP. So if I say the difference here is A, the difference here has to be A plus D. The difference here, here and here has to be A plus 2D, A plus 3D, A plus 4D, and then A plus 5D and A plus 6D. Let me confirm. A plus D, A plus 2D, A plus 3D, 4D, 5D and 6D. 1, 2, 3, 4, 5, 6, 7 and 8. I want the eighth term. So I have to find A and D. So what I get here is, here the term is A plus 2. Here the term is A plus 2 plus A plus D. A plus 2 is the second term, plus A plus D is the third term, that is 10. So I have got 2A plus D is equal to 8. Now, here with 10, observe with 10, if I add a plus 2d, a plus 3d, a plus 4d, I will have 3a plus 2 plus 3, 5 plus 4, 9d plus 10 is equal to 37. These hints are there to help me in finding a and d, and then my job is done. So I've got 3a plus 9d is equal to 27. So I need to solve first and second equation. So I need to find a and d and put those values further to get my answer. Let me complete this for you. If I make this equation 3 times and this equation 2 times and subtract, a is gone. So 18 minus 3d is 15d. 54 minus 24 is 30. So I've got d is equal to 2. If d is equal to 2, a is equal to 3. So please observe, d is equal to 2. So this becomes 3 plus 10, 13. And this becomes 3 plus 12, that is 15. So from here I need to add 13 and 15. That gives me here 28. 28 added to this, 28 added to this, 37 and 28 will give me 65. That is my value here, guys. 65 is the last value. That is the 8th value. This was a slightly elaborate problem. We had to find a and d. There is one hit and trial based approach, but I will not be covering that here. That involves your understanding of squares and their differences. Basically, if you notice, this is 1 square plus 1, this is 3 square plus 1, and this is 6 square plus 1. This is going to be 8 square plus 1. That is very high level hit and trial. I don't expect you guys to understand that. Skip that for the time being. What does this problem say? X and y are positive integers such that this is true. An equation was given. This is a memory based question, guys. What is the minimum value of x minus y? For minimum, I'm looking for x to be less and y to be more so that I can have minimum difference. Negative will be preferred. So whenever you come across equations like ax plus by is equal to 1 into xy, understand this 1 is absolutely necessary. That you can simplify directly in this form. And I see I have an equation 2x plus 3y is equal to xy. I can directly simplify this as x minus 3 into y minus 2 is equal to 6. Now I will break down this 6 in a manner that I have integer factors. I can break it as 1 and 6, 2 and 3, 6 and 1, 3 and 2, minus 1 and minus 6, minus 6 and minus 1, minus 3 and minus 2, minus 2 and minus. There are multiple ways to break this down. But let us not lose the focus here. I want x to be minimum. So I would want this bracket to have largest value possible, negative. That is minus 6. I will assign x minus 3 as minus 6. I will have x is equal to minus 3. Why? I want x to be negative. I want x to be less. I will assign minus 1 to this bracket. I have y minus 2. Y minus 2 is equal to minus 1. That gives me y is equal to 1. So y is equal to 1. That is the largest value I can get in this way. So what do I get here? If I put minus 3 minus 1 here, I have got minus 4. Guys, that is my answer for the minimum value possible for x minus y based on these conditions. This was the learning objective, guys. If you copy this down and remember this, it will be easier for you to solve all such problems. Anytime you come across ax plus by is equal to xy, you will always be able to break it down as x minus b into y minus a. So I'll see you in the next video. In the next session, I'll be trying to solve for you questions of algebra from CAT 2017. Notice we have solved 20 problems just now. These are memory based. So there were 10 questions of algebra in morning and the noon slot of CAT 16. Understand, there are always 12 to 13 problems nowadays of algebra in CAT in every slot. So algebra, guys, will need due respect and amount of time that you can give it. So I'll see you guys in the next session. Have fun. Bye bye.